In this video, I'm going to be talking about hypsometers and how to use them when you're applying trigonometry with indirect measure. So a hypsometer could be this fancy device that contractors use, people who need to measure things indirectly. So maybe this guy's seeing how tall a tree is or a building. And this does all the trigonometry for you as long as you put in how far away you are from like the building. It'll figure out the angle and how high that building is. So we have this fancy technology over here with a protractor, and then tied to the protractor is a string with a weight so that you can rotate the protractor up and down, but that string will stay constant, like straight down to the ground. Thanks, gravity. And then on top of the protractor is taped either a laser pointer if you have one, or you can just use a straw, like something you're going to look at so you can locate the top of the building and make sure you get the angle correct. Building, flagpole, what have you. I just looked up a hypsometer on Amazon and it ran about like $300. The second one that came up was about $700. So we're going to get like an approximate answer, like approximate way to measure this for free. So let's see how we're going to use this. Okay, so here's you looking good, and here's your hypsometer. So this can rotate, and here's the string with the weight on it. Okay, and your eye is going to be at this corner of the protractor, right? So we're trying to measure how tall the flagpole is. The information that you need to know to be able to do that is how far away you're standing from the flagpole. So I know I drew the person here, but ideally your feet would be right here. Like this is where you're standing, right here. So let's say we measured it out. We had like a tape measure or whatever, and from here to here is 14 feet. The other piece of information that you need to know is basically how tall you are. Everybody knows that. So I'm not this short, but let's say for simplicity's sake that I am 5 feet tall. Well, that's definitely the distance from the ground to my eyes. Okay, so then what we're going to do, so that's like here to there. We are going to take the protractor, look into the straw or use the laser pointer, and rotate it until you see the very top of the building. So like your eye will be right here. So you're not like bending over or anything. Like you're this tall, here's your eye, here's the top of your head. Okay, so maybe I'll just draw a little eyeball right there. So here's your eye. Looking in up at the, yep, looks just like an eye, up at the top of the flagpole, or you're pointing at it with a laser pointer. And what's happening is this weight is staying constant, and we can actually measure this angle here with the hypsometer. That's what the hypsometer does. It measures that angle. So this is hard to see, so let me enlarge this. Okay, so it's 151 degrees. So the entire red angle is 151 degrees. So this is a 90-degree angle, and I don't care about this part. I want to use this triangle here that I drew that includes my line of sight, this height to the flagpole, and then this hypotenuse. So what I'm going to do is 151 minus 90 to figure out what that acute angle is. Okay, so 61 degrees. So what we know is that this angle here is 61 degrees. Oh, I don't want to make that bigger. Go away. This is 61 degrees. 61. And then the other information that I have to know is that from here to here, Like this is about where I'm standing. It might be off by like a couple millimeters when you're actually doing it. Is 14 feet. And I'm going to figure out how high it is from here to here. And the reason why it's okay that I only find this distance, like from this line of sight to the top of the flagpole, is because I can find that and then add my height to it. So I'm finding like the remaining distance, not including my height on there. So I'm going to call that x. That's what I'm trying to find. And then this is where the trigonometry comes in. So I have the 61 degrees, and then across from it, what I'm trying to find, that's the opposite side, and then the 14 is the adjacent side. So because it's opposite and adjacent, this is going to be a tangent problem. So I'm going to say the tangent of, it's so hard to write with the mouse pad, 61 degrees is equal to x divided by 14. And so x is equal to 14 times the tangent of 61. So that's the exact answer. So the approximate answer, you'll use your calculator. So I'm going to do that really quick. So I have 61 degrees, the tangent of that multiplied by 14. So this flagpole is approximately I get 25.26, that's rounded to the hundredths place, when I figure out the tangent of 61 times 14. But then you need to add 5 to that, my height. So that's going to be different for everybody, depending on who is measuring it. You know, if Kareem Abdul-Jabbar was doing this, he'd be adding a bigger number. Okay, so I'm going to add 5 to it, and I get 30.26 feet, which I definitely couldn't have done with just a tape measure. So, in summary, hypsometers, pretty cool. Trigonometry, even